Hi, this is part two of a presentation trying to give you a feel for how to make calculations of the rates of Grand Canyon deepening and widening. Part one went over the incision rates for the north rim and the south rim, and I'm continuing where I left off. I'm going to start sharing the screen. And in the screen sharing, there's two pieces to it. One of them is the Grand Canyon game, and the other one is this Word file I'm using as kind of a scratch pad. Where I left off was that the elevation of the north rim is measured in the game up here with the avatar is 2611, and the elevation down at the bottom of the Grand Canyon is 721 meters, and it's 1890 is the meter difference between these two. You can check the math if you add them up. 1129, carry the 1, and you get it close. 1890 meters is close to 2,000 meters. 2,000 meters is the depth of incision from the top of the North Rim down to the bottom of the Grand Canyon. So if you move the rabbit down the bottom, you could almost picture the river of the Bright Angel Creek slowly incising, slowly cutting down at an incredibly small, low rate of just 4/10 or a little bit less than 4/10 of a meter every 1,000 years. But if we know the Grand Canyon started to form 5 million years ago, or 5,000 millennia, that rate translates to a little bit less than 0.4 meters per 1,000 years. By trying to do this back of napkin calculation, you can make sure that the real calculations you do when you work on the lab, you're in the right ballpark. So let's stay in the game of the right ballpark, and let's see what happens if you do this per year. So 5,000 millennia is the same thing as 5 million years. So if you change it from millennia to years, you have to add in 3 zeros here. It's a really tiny amount. And we have to change the units there. In fact, 0.0004 meters is the same as 0.4 meters per, I'm sorry, 0.4 millimeters per year. So by going from 5,000 millennia to 5 million years in the denominator, if you change this from meters to millimeters, 2,000 meters is the same as 2 million meters, and it's the same. So meters per 1,000 years is the same as millimeters per year. The next calculation I'm hoping will be a little bit easier for you to visualize because it's the same concept. Let's look at how fast the Grand Canyon is widening. To know the rate of widening, you need to know the length, how far it is from, let's say, the North Rim down to the bottom of the Colorado River. So put another way, the bunny rabbit is stuck down here in the middle of Bright Angel Creek. And if you're looking up at the North Rim, where the bunny rabbit is only a piece of the way, all the way down to the Colorado River. I'm going to tell you that the length of Bright Angel Creek is 17,000 meters. That's ballpark. That's how far it is from down at the Colorado River all the way up to the headwaters of Bright Angel Creek. And you already know that the Colorado River started to form 5 million years ago. So let's try the math again. 17,000 meters. Bright Angel Creek eroded headward, eating back up into the Kaibab Plateau over a 5 million year period. That's the same as 5,000 millennia. So the math would be 17,000 meters divided by, let's put it on the same page, 17,000 meters divided by 5,000 millennia, or 1,000 years. It's the same as 5 million years. Try the math again. Look at 17,000. I hope you can see that 17,000 is a little more than 3 times 5,000. So it's just a little bit more than 3 meters per 1,000 years. So the rate of the Bright Angel Canyon eroding headward is a little more than 3 meters per 1,000 years. And if you remember the rate of incision, it was less than 0.4 meters per 1,000 years. So I hope you can see that the rate of widening at this particular place with Bright Angel Creek is, let's say, it's about, so let's divide 3 divided by 0.4. And again, it's a little more than 3 and a little bit less than 3.4. Let's try to get ballpark. 32, right? 3.2 is a little more than 3. 3.2 goes into 4, about 8, right? 8 times 4 is 32. So the rate of widening at this particular location is in the ballpark of about 8 times as fast as the rate of deepening. Let's try the south rim. The south rim from the Colorado River to the south rim, I'm telling you, is about 6,000 meters, but let's just fast travel there in the game. So we're up here, and let's have the rabbit jump down from the south rim down towards the bottom of the Grand Canyon. So if you remember, the rate of deepening is quite slow. What's the rate of widening? 6,000 meters from here in the Colorado River to this point here at the head of the canyon where the South Rim facilities are, where you start the Bright Angel Trail with all the burrows and the poop on the trail, if you've ever been there. So 6,000 meters divided by 5 million years, which is the same as 5,000 millennia, or Ka. That's really close to 1. That's just a little bit more than 1 meter per 1,000 years of widening. The North Rim was a little bit more than 3 meters per 1,000 years. So the rate of widening on the north rim at Bright Angel Canyon is about 3 times the rate of widening on the south rim. What about the comparison of the rate of deepening? So we did the deepening calculations, and it was less than, well, actually, let's just skip it, and I'll stop the video right now. And I hope you get the idea that I want you to be able to just estimate these numbers, because I'll tell you up front, the answers that you deal with in this class in the multiple choice, there are big differences between the answers. We don't want you to obsess on the precision. In other words, that it says 921 meters at the bottom of the Grand Canyon. That's not a very precise measurement. That's just based upon the best elevation we have. That's what's in the DEM. So we're never going to get that precise in terms of decimals for making any of these measurements. Therefore, in the Canvas choices in the question, there are going to be big differences. So being able to make these back of napkin calculations and estimations to get a feel for the rate of deepening, widening is all that we really want out of you. And the ultimate goal here is for you to just get an appreciation of the wow and the wonder that when you visit the Grand Canyon and you wander around this virtual world quickly, much faster than you can ever hike, I want you to come away with an appreciation for just how slow these processes operate, but the slow and steady progression of these processes produce such a magnificent landscape. I hope you have fun and enjoy it.